Lesson 3 is over air currents. What we're mostly going to be talking about is winds. Our vocab here, first we have wind, movement of air from high pressure to low pressure areas. This is going to be very important, just like almost everything in nature. It wants to go from high to low. It wants to balance everything out. Trade winds are steady winds that flow towards the equator from east to west. Westerlies are steady winds that flow from west to east. Polar easterlies are cold winds that blow from the should be east to the west near the poles. Jet stream is a narrow band of high winds. Sea breeze is wind that blows from the sea to the land. Remember, if it's a sea breeze, it's sea to land. Land breeze is the exact opposite. It blows from land to sea. So they're naming them by where they're originating from. Alright, global winds. The angle at which the sun's rays hit the earth determine the intensity of the heating. Latitudes near the equator take much more direct sunlight than those near the pole. Latitudes near the pole have much lower angle, which leads to less direct sunlight. Warm areas have low surface pressure, while cool areas have high surface pressure. That surface pressure comes from heating of the air molecules. Air moves from high pressure to low pressure. We'll explain this more when we go over the notes, as far as what we mean when we talk about direct sunlight. Global wind belts. The prevailing winds are the name for three cells. There are three cells in each hemisphere that create the northerly and southerly winds. The Coriolis effect causes them to blow to the east or to the west. At 30 degrees north or south, there's a lack of wind. These areas are called doldrums. The three wind belts are the trade winds, the westerlies, and the polar easterlies. The trade winds occur between 0, so the equator, and 30 degrees north or south. At the equator, warm air rises. Remember that. You're always going to know that warm air rises. At 30 degrees north or south, the warm air has cooled down enough to sink. These cause convection cells. So what happens is, and we'll see this later in the picture, is that as the warm air rises, cool air moves underneath of that warm air. And we say warm air rises, that's not entirely true. Part of it is that the cool air is always pushing from underneath. So the cool air is moving in, and the warm air is being pushed up. So this warm air goes up, and it's carried north or south, depending on where it's at, up to about 30 degrees north or south latitude. When it gets to that point, it's been high in the air so long, and we know that in the troposphere, the higher we go, the higher the altitude, the colder the weather, or the colder the temperature. So it starts to cool back off, and when it gets to 30 degrees, it's cool enough that it starts to fall again. And this makes its convection cells. So the westerlies are between 30 and 60 degrees. These are not convection cells, but they are driven by the convection cells on either side of them. So the westerlies themselves aren't convection cells, but they depend on the convection cells of the other two prevailing winds. The polar easterlies are 60 degrees to the pole. At the pole, air sinks because it has become cold. This makes sense. North and South Pole, we know, are very cold, so this is going to lead to cold air. At 60 degrees, the air rises because it is warmed up. This is another example of a convection cell. So this is almost the exact opposite of what happens during our trade winds. In this case, we're going from a cold area and we're moving towards the equator, and then when they get closer towards the equator, they start to heat up and they rise again. So here's what we have. We have our trade winds. In this case, are blowing. We have northeast trade winds, southeast trade winds, and they're blowing towards the. Don't worry about the intertropical convergence zone too much, but know that the trade winds are blowing towards the equator, right? Because the air is going to move. The cool air, the warm air is going to come from right here, and it's going to go up in the atmosphere to this point. When it gets to 30 degrees, it's going to start to sink, and when it sinks, it's going to start moving back towards the equator. This is just accounting for north-south. We'll talk about why it goes east and west later on. When we have the westerly, actually, let's talk about the polar, the polars, or polar easterlies, excuse me. They don't give us pictures here, but the same thing happens. The air cools here, and as the air cools, it starts to come down in altitude, and then it goes across the land, and when it gets to about 60 degrees latitude, it warms up enough to the point where it starts going up again, up in altitude. When it goes up in altitude, it starts heading back towards the poles. So, what we're left with are the westerlies. And these aren't convection cells themselves, so they don't rely on that heating and cooling as much as they rely on these other two convection cells. We know that most of, if you've ever watched the Weather Channel, most of our weather happens from west to east. Right? If we have a storm blowing in, it's going to blow from western Nebraska all the way across to eastern Nebraska, with a few exceptions. But that's why that happens, because we are in the westerly zone. So the Coriolis effect, the Earth rotates from east to west when it spins. Objects in the northern hemisphere seem to trail right as you are watching them from the original point. In the southern hemisphere, they seem to trail left. This is the Coriolis effect. It creates the prevailing winds. So the one way to think about this is that if you were on a merry-go-round and you rolled a ball, and you're spinning the merry-go-round, and you rolled a ball, a tennis ball, across the merry-go-round, it would seem to trail right, depending on which way you're spinning the merry-go-round. We'll watch a few videos over this to get a better understanding. In your book, we don't talk about this in the book very much. Jet streams flow from west to east. They make very large loops, north or south. They affect weather by bringing cold air to tropics or warm air to the poles. I believe it was last year we had that polar vortex, and I think that was part of the jet stream. Made it really, really cold during the winter. They can travel as fast as 300 kilometers per hour, and they are more unpredictable than our prevailing winds. So here we have what the jet streams can look like. We have a subtropical jet and our polar jet. And if this happens to dip down right here like it did last year, then it gets really, really chilly. Local winds occur because of pressure differences, just like other winds. The sea breeze, when land warms faster than water. This is an important thing to remember. Land warms faster than water. This heats the air over the land, which makes it become low surface pressure. Because we like to think that warm air rises. So that means if the warm air is rising, there's not as much pressure on the surface. The air over the water is still cool. So this leads to a high surface pressure. The pressure moves to balance out. Wind moves from high pressure to low pressure. So in this case, we're moving from the air over the water to the land. So again, sea breeze tells you where it's coming from. It's coming from the sea. Land breeze. At night, the land cools faster than the water. Just like it heats up faster, it cools faster as well. Thus, the air above the land is cool, creating a high pressure. This leaves warm air above the water, which creates low pressure. The wind moves from high to low pressure, so we move from the land to the water. So here we have our examples. Here we have a sea breeze because we're moving from water to land. This is telling us the direction. So here we have high pressure. The high pressure wants to go to low pressure. When it gets to this point, the land heats it up, and that hot air rises. Again, I use that word kind of loosely. I don't like to think about hot air rising because that's not exactly true. It's more being pushed up. When it gets to that point, we have high pressure up here. So it wants to move to the low pressure up here because When we get to this point, it starts to cool and then it comes down again and becomes high pressure. And that's for a sea breeze. On the right side, we have the opposite. We have the land breeze, where we have cold land making it high surface pressure. The high surface pressure wants to move to a low surface pressure, which is caused by the warm water. And then we have the warmer water heating up the air, air moving from high pressure to low pressure. And that continues. That will do it for this slideshow.